Hey, Mr. Estrada here. Our aim for the video is how do we write functions in functional notation and how do we evaluate functions for given values in the domain. So as a little warm up, I'm giving you the equation y equals 3x minus 2, and I want you to find the values of y for x equals 1, x equals 2, x equals 3. So pause the video and think about that for a second. So one of the ways we can approach this is by making a table of values. We have our input over here on the left side. We have our equation or our formula here in the middle. And we have our output here on the right side. So our inputs are x. So when 1 is inputted, y is outputted. When you input 1 for x, 3 times 1 is 3. 3 minus 2 is 1. When you input 2 for x, you get 4 for y. When you input 3 for x, you get 7 for y. So if you got 1, 4, and 7 for x equals 1, x equals 2, and x equals 3, you are correct. Okay, so if you recall, a function is a set of ordered pairs in which each x element has only one y element associated with it. One way you could think of a function is as a machine where something is inputted and it goes through a rule and something is outputted. So if we look at our previous equation, we could think of it as a function because something is being input, so x is being input and y is being output. So a function is a set of ordered pairs in which each x element has only one y element associated with it. But you can also think of it as a factory or as a machine that produces something. Something goes in and something comes out. Something is produced. Now, functions are traditionally referred by the letter f. So if we want to write y equals 3x minus 2 in functional notation, we can use the letter f and we can rewrite it as f of x equals 3x minus 2. So traditionally, functions are referred to by the letter f. So if we're going to write y equals 3x minus 2 in functional notation, this would be the traditional way of writing it. Now, even though traditionally functions are referred to by the letter name f, f need not be the only letter used in function names. The following are but a few of the notations that may be used to name a function. F of x, g of x, h of a of t, and so on and so forth. So these are one of many ways that you can rewrite y equals 3x minus 2 in functional notation. Note, the f of x notation, or any of these other notations, can be thought of as another way of representing the y value in a function, especially when graphing. The y-axis is even labeled as the f of x axis when graphing. Okay, so now you try it. Rewrite y equals x squared minus 2x plus 2 in functional notation. So some acceptable ways of rewriting the above in functional notation would be like this. These are some acceptable ways. So this is functional notation. Okay, now evaluating functions. To evaluate a function, you simply substitute or replace the function's variable with the indicated number or expression. So take a look at example 1. A function is represented by f of x equals 2x plus 5. Find f of 3. So since our function is represented by f of x equals 2x plus 5, to find f of 3, all we have to do is substitute for x. So f of 3 would be 11. 2 times 3 is 6. 6 plus 5 is 11. Remember, think of a function as a machine. Something goes into the machine. In this case, 3 is going into the machine. And it's going through this process of being multiplied by 2 and having 5 added to it. And it's going to output f of x, which in this case is 11. Okay, now you try. A function is represented by h of x equals x to the third plus 3x squared minus 5x minus 6. Find h of negative 2. And then go ahead and try the second one. Pause the video and think about it. Okay, so for number 1, we want to evaluate for h of negative 2. So we substitute for x with negative 2. Negative 2 to the third power is negative 8. Negative 2 to the second power is positive 4. That times 3 is 12. Negative 5 times negative 2 is positive 10. Bring down the minus 6. Combine the like terms. H of negative 2 is 8. Number 2, find the value of h of x equals 2x squared plus 6x minus 3 when x equals 4a. Now, notice that this time we are substituting an expression. So we're going to write h of 4a equals 2 times 4a squared plus 6 times 4a minus 3. So essentially, we're substituting x with that expression for a. Now, this is important. Since you're substituting an expression, the end result should be an expression. So 4a squared, that's 16a squared. 6 times 4a is 24a. Bring down the minus 3. 16a squared times 2 is 32a squared. Bring down everything else. This is the final result. Notice, as I stated before, that the final answer is in terms of a, and that's because an expression was substituted. If you want to practice some more, go to this website and you can practice some more there. I will provide the link in the comment section. Thank you for watching. Take care.